about anything are driven by the standard model completely. And there's lots of interesting things we could say about all these other possibilities. What I want you to notice in all of these, right, is that the question being asked, well, not E, but the question being asked is something that has to do with either are their preferences reference dependent, or perhaps more importantly, in all of those cases except B, what is their reference point, right? Who do you compare yourself to, and what about that person do you compare yourself to? So just as an example, for C, yeah, I can believe that I would start wanting to earn more money if my next door neighbor just bought a new car. But why? If my next door neighbor just bought a new car, guess what my next door neighbor now has less of? Money. So has anything material about them changed? No, they're just consuming in a way that I can see every day, right? So the point of all that is simply to say, we really, when we start thinking about what is a particular person or a particular population's reference point in a particular situation, it starts to become very hard to figure out. So I want to talk about specific models of where reference points come from. It's a question that has not been at all satisfactorily answered, although in a strange and annoying way, a lot of behavioral economists have gained the impression that it has been satisfactorily answered and have moved on, which is one of my pet peeves about this field. I don't know if I'm going to have time to dwell on that today. So partly I want to show you what's been done in terms of modeling how would we predict what a person's reference point is in any particular situation. Mostly what I want to do is I want to use this as an opportunity to talk about an extremely important feature of the sort of the process of doing economic research, the process of developing models and theories. The thing is, what we've accomplished so far is that we have proved very conclusively, in most people's opinion, over and over again, in the lab, in the field, in lots of different markets, lots of different behavioral choices, that the standard model without reference dependence, without loss aversion, in a lot of cases without narrow framing, doesn't work, is wrong. Okay? The assumptions are wrong and need to be changed. What we haven't accomplished yet is we don't have a complete substitute, right? So a lot of people will say, you shouldn't criticize unless you can do better yourself, which, by the way, is wrong. You should criticize if you think that the person changing their behavior would make the world a better place, even if you don't have a better solution. You might get them to find a better solution. But setting that aside, we haven't completed the task because we don't actually have a complete replacement for the standard model. Right? The standard model is complete. It says there is no reference dependence, so I don't have to worry about the reference point. I'm telling you that it's based on preferences and wages and income, and I can go out and I can run a bunch of econometric models to tell you exactly what those functions look like. Here, we come and we say, no, you're wrong about that. It's based on some kind of reference point, but we don't actually yet have any way of telling you what that reference point would be in a situation we have not yet observed. Right? That's the point of this question. We know something pretty important about what it is for married women. We don't actually know anything. We can't use that to predict with any degree of accuracy what the reference point will be for unmarried women or anybody else, and particularly not in some other situation.
So at the end of the last lecture, you said why we use standard model first. Critics of that impose in it is that the answer that there is a substitute.
It's in lots of cases it's simply because, well, there's a couple of reasons. The reason I was getting at there and here too is that I'm going to keep using the square wheel until you can actually bring me a round wheel that really works. Right? If your round wheel doesn't have an axle, it's a theoretically interesting concept, but I need an actual wheel, so I'm going to keep using my square wheel. Yeah, that's the bottom line. The model has to be able to do work. And in particular, the work that the model has to be able to do is it has to be able to allow you to predict what's going to happen in a situation you haven't yet observed, right? Otherwise, we're just sitting around explaining things in ways that no one can refute, right? So there's a so-called academic field referred to as evolutionary psychology, right? Where we go out and we say, here are these interesting psychological findings. Now I can show you how they're explained by some evolutionary advantage that you got. And then what you want to ask yourself is, would that theory predict the next evolutionary change? Because if not, it's just a story I came up with. And if the facts had been different, I could have come up with a story for those facts too. You can always come up with a story to explain facts. Science advances by coming up with a story that explains things you've already seen and correctly predicts things you haven't yet seen, because otherwise you can't test whether your theory is right or not. Okay? So that's what's going on. And then the other thing, of course, is that a model that doesn't predict things empirically in a positive sense, a model with which you can't do, say, for example, policy analysis. What will happen if I do the following thing? What will happen, to the labor supply of unmarried women if, say, the earnings of married women go up? A model that doesn't predict that, it's like having a model of gravity that doesn't allow you to actually measure the actual force level of, the force of gravity on any given planet. It's like, great, take a theory of gravity that says that apples will fall out of trees, but unless you can tell me how fast they will fall, you're not really doing much useful work in the world. Okay, so I actually think that I've said enough to cover the slide. I'm going to skip it. Yeah, I've actually said everything on those two slides, so I'm going to jump ahead. Okay, so here are a few candidates for the reference point that people have used to try to plug into models. And this is sort of in a progression both chronologically in the history of the field and also in terms of gradually making the model more sophisticated. So the first one is the status quo, which we've already talked about, which is the reference at point in time t is just equal to consumption at that point in time t. Right, so this explains the mug experiment. I put a mug on Timothy's desk. His status quo immediately becomes, I got a mug. It explains these contingent valuation surveys. I tell you that I'm just about that your endowment is Yosemite plus 1 acre. It immediately becomes your reference point because that's your perception of the status quo. It's clearly wrong in a lot of cases, right? So I showed you this thing where you had a bridge that broke a month ago, and you guys all had loss aversion over the loss in travel, the increase in travel time, the loss of sort of traveling efficiency. And then I asked you, okay, well if it had been broken the bridge broke last month, which means that if the status quo was the right answer, your reference point would be a broken bridge and 10 extra minutes of driving time. But what's really going on, I think intuitively you all saw this, is that you've been crossing the bridge with the short travel time for years, and the month your reference point hasn't changed in the course of a month, and then you mostly acknowledge that if I just let 2 years go by, your reference point would have changed. So status quo isn't quite right. Okay, so we have the next sort of refinement is to say, okay, it's lagged consumption, right? In time series analysis, a lag variable means that variable in the past, in the last period, or going back. So this is a very simple math. There are different ways you can model this. This is a very simple and common way of doing so. Is that you just say the reference point today in time t is a mixture of the consumption yesterday, my lagged consumption from yesterday or last year, plus somewhat like what my reference point was yesterday as well. So my reference point was no mugs. My reference point yesterday was no mugs, and then I got a couple of mugs. So by today, my reference point today is kind of a mixture of those two, and it's what we would call a gamma mixture. Gamma is a number between 0 and 1, so it's kind of a mixture of the two. So it's gradually changing over time, right? Is what's captured there. So I wanted to spend some time dwelling on this cute little lagged consumption model, but I'm going to breeze through this a little bit. So this is a better model in many cases, obviously. So it explains the persistence of the bridge reference point, right? Because if the time period is a month, well, last month your consumption was one fixed bridge, and you're slowly adapting to it being broken. So it allows for persistence and for adaptation. It's nice because it has this simple parameter gamma, which basically captures how fast your reference point adapts, which is really nice because the speed of adaptation is a really crucial question. If gamma is high, it implies that you adapt really fast, right? So if gamma is 1, it means that your reference point immediately adapts to what happened in the last time period. If gamma is very low, it says that what happened in the past reference point, sort of drags on far into the future. So it's a nice, elegant model that captures the rate of adaptation. Yes?
I was going to ask why you're lagging the consumption, because if it were a true mixture of the two scenarios, wouldn't it be the consumption of today, so it would be T, and then the lag of the reference?
So,
why are you time lagging both of them? When does it come into play?
So when would you? So in other words, I think. So let me see if I can reframe that. The trouble I have with this model is that it gives absolutely no power to the immediate status quo.
Right, exactly.
Right, which we know is wrong because I can tweak Timothy's reference point in the space of about 15 seconds with a mug.
Right.
And I've been meaning to talk to him about that.
So I was just wondering why you're proposing as a mixture of the two scenarios when it's really just the second scenario. Or you're proposing as a new model?
It's a new model. It's either right or wrong. One of the ways in which, well, I mean, so here's the thing. It partly depends on how fast this all happens. So when you put the mug down in front of somebody, like when exactly, like 10 seconds, 20 seconds, 2 minutes, how fast does their reference point adapt? And the thing is that it probably varies, right? You probably don't adapt to the bridge being broken, right, as fast as you adapt to being given a mug. But the exact second at which the mug comes down on your desk, which would be the exact immediate status quo, who knows if that counts for anything or not. This model is ambiguous as to what the length of the time period is, how big gamma should be. It's not perfect. It's just a way to capture sort of a simple idea. Yeah?
Wait, this is just calculating the new reference point and then you put that into another utility function, right?
Bingo. Yeah. So the reference point in the utility function, the way we've been doing is I've been saying R, the reference point, is an exogenous parameter. What we're trying to do is we're trying to make it endogenous. We're trying to explain it within the model.
Just wondering why this model uses
That was the same question. Yeah. So you guys need to talk for a couple minutes after class, see if you can figure out what the implications are of changing it to CT instead of CT minus 1, and send me an email.
Just to add one thing, why would you do a model that adds both like the current CT and the previous? Because when you care about both what your previous
You might.
and your current endowment.
You might, but you might decide not to spend your time on that because this is already wrong in lots of ways, more basic ways. So, but do keep thinking about it. Talk to, your name was Henry? Caroline? Caroline. Okay, so you guys have a paper to write together. I'll advise you on it. I'm gonna skip this, I'm afraid, but everybody really quickly click your button. I'm sorry to do this. I hate doing this, but otherwise I have to tweak my participation point system. That's annoying. Okay. Bing, bang, boom, 10, 6, 1, stop. Okay. So where we go from this is, so we observe that lag consumption is also clearly wrong. So here's an example. I already gave you the example of like, you're told you're going to get a wage increase at the end of the year, then towards the end of the year you're told no, you're actually not going to get a wage increase. It's pretty obvious that that is going to make you unhappy because you've gotten used to the expectation that your wage is going to go up. This happened a couple years ago. First, the Department of Education announced a large increase in Pell Grants, a large increase in the income threshold for Pell Grants, effective in January. And then Congress, I don't think they actually did pass this law, but they sure threatened to in December, saying, no, you can't do that. You can't make any changes to the Pell Grant system. You can believe that a whole bunch of people who are looking forward to getting that Pell Grant so they could pay for their education experienced that new law, or would have experienced that law as a loss relative to an expectations-based reference point, which may very well contribute to why that law wasn't passed, because basically people rise up and say, no, I have my expectations set. So along come Botan Kosegi and Matt Rabin. We've seen him before. Botan used to work here. In fact, he taught this class before I took it over. He went back to Hungary to work in his home country. And what they say is that the reference point for evaluating outcomes should be recent expectations about those outcomes, right? So I think the example they give is if you expect a painful dental procedure and you go in and it turns out all you need is a checkup, it's going to feel like a huge gain. And then there's this other example. You can read the paper. The introduction should be relatively easy to understand. The rest of it I think is very difficult. So why recent expectations rather than your current expectations? So the idea they have is this, is that when I give you new information, you're going to get a raise. Your expectations change immediately. Oh, my expectation is that I'm going to have more money. But that your reference point doesn't necessarily adjust to those new expectations right away. Okay? So that if I told you that you're going to get a raise, and then my assistant comes in and says, no, I'm sorry, it was Dan Aykroyd, not Dan Ackland, who was supposed to get the raise. Oh, I'm fairly sorry, Professor Ackland, please go away. That I'm not going to experience that as a massive loss, just an annoyance. Okay? So the idea is expectations adjust immediately, but a reference point takes time to adjust to the new expectations. That's the basic idea. This model embeds lagged consumption as one of the things that affects recent expectations, because if you don't expect anything else to change, then the recent past should be a reasonably good predictor of the future. But it says a lot more. Okay, so there's a study here. Oh, this is annoying. What I need to do is I need to teach this as a 2-semester class. This slide is completely self-explanatory, so please read it. You can see exactly what it says on your own. I don't need to repeat it to you. Here's what I do need to say to you, and this is very important because this is a big part of what you need to know for the problem set, you'll get this in more detail in section and in office hours as needed. So here's what the Kosegi-Rabin model says. It says that the reference point at any point in time is based on the expectation of your future consumption, right? The expectation of what you'll have in the future, given what your reference point will be in the future, as well as sort of the prices and a bunch of other stuff that we capture in theta. So given prices and a bunch of other things, given what you believe your reference point will be in the future, and what you believe you will consume under that reference point, your reference point will be your expectation of your consumption. This should bother you because it's circular, right? It's circular in this very annoying way. Not annoying, it's circular in a very challenging way, okay, which I'm going to ask you to wrestle with on the problem set. Basically what it does is it says, your reference point is going to be your expectations of your consumption, where those expectations are based on the utility maximization problem you would do if your prediction of your reference point was correct, which means that your expected consumption has to match what your reference point would be if that was your actual future consumption, right? So you have to be able to predict a lot of things. You have to be able to predict how your future consumption would respond to different reference points, and you have to be able to predict how your future consumption would respond to different reference points, and then figure out what consumption bundle would actually result in a reference point that is the same as the reference point necessary to get you to that consumption bundle. Okay? Okay, I've explained this twice in 2 different ways, and by the time I get to 5, you may understand it, but unfortunately I only have 4 ways. The idea here is an individual's reference point at a given point in time is their expectation, which is to say their prediction of their future consumption, under the assumption that their consumption will maximize their preferences given what their reference point would be if they're right about what they would consume under that reference point. Okay? So it's circular. You have to predict what you would do under a range of different reference points, and then your consumption actually has to be whatever would result in the reference point that gives you that consumption in the future under utility maximization. Okay, I said that 3 times. Let me give you a specific example. So the bottom line is the model doesn't allow you to believe that you will do something that you know you won't actually do. Okay, so here's a specific example. Suppose you start from an endowment of 0, 0, and you know that the price in the future is going to be P. The buying price is going to be P. If you expect to buy a mug at that price, like say the price is $2, if you expect that with a price of $2 you will buy a mug, then what that means is your expectations-based reference point is going to be 1 mug minus P dollars. So it better be the case that when your reference point is 1 minus P, buying a mug is actually utility maximizing. Okay? What you can't do is you can't say, oh, my reference point is going to be buy a mug, if in fact under that reference point you would prefer to not buy a mug. Okay? So buying a mug, in order for buying a mug to be a rational and legitimate reference point in this model, it has to be the case that you would actually buy a mug if buying a mug was your reference point. Okay? And if, under the reference point of I'm going to have 1 more mug, my expectation is in the future I'm going to have 1 more mug and P fewer dollars, if you plug that reference point into your utility function and discover that actually the utility maximizing thing to do with that reference point was to not buy a mug, then that cannot possibly have been your reference point, because it means that you must have been mispredicting the future. You're thinking to yourself, no, if I buy a mug, I really will want to buy a mug. When in fact, if you get there and that's your reference point, you actually won't want to buy a mug.
Oh, just what was theta?
Oh, theta is just a bunch of other information, the weather, stuff like that. It's a vector of everything else you might need to know about the world. You know, price of coffee, things like that. Okay. So the point of all this is that the Cossetti-Rabin model requires, it assumes that you have rational expectations, right? You have rational expectations if your beliefs about the distribution of future parameters and preferences are correct. In other words, if you are in general right about how things are going to unfold in the future, and in particular, if you're right about how things are going to unfold in the future as a result of your choices. Okay? If I plan to buy this mug, it means that my reference point will be based on an endowment in which I have 1 more mug and a little bit less money. It has to be the case that you also correctly predict that when that's your reference point, you will actually want to buy a mug. Okay? So it requires that you predict a whole bunch of stuff. Now, one of the things we're going to talk about for the rest of the semester is how this assumption that people correctly predict things in the future shows up all over the place in the standard model and all kinds of ways in which it's wrong. The point I want to make here before I let you go is that Cossetti and Rabin, a couple of very famous and successful behavioral economists, basically rescued the reference dependence model by coming up with a theory about the reference point that depends upon a massive assumption of rationality. It's not entirely obvious that that's the right way to proceed. So that's that. And I won't be here Tuesday because it'll be your GSI is giving you an exam review. I strongly encourage you to be here for that. And I'll see you next Thursday.